Sometimes the data that you're dealing with in your frequency distribution table is nominal. Nominal means that instead of collecting a bunch of numbers, I'm collecting categories. So I'm checking to see how many times an M&M that came out of a package was blue, or how many times an M&M was orange, and so on. So this would mean that my observations are nominal or categorical in nature. If that's the case, I'm not going to use a histogram. I'm going to use a bar chart, which I will show you is very similar in this video to a histogram, but not quite the same. It's got one major difference. Nominal data, I want to use bar charts, but also ordinal data. I'm going to use bar charts. And that's in contrast to times where I'm dealing with proper numerical data like interval or ratio data. And in those cases, like the videos that I've already done, where I drew histograms, interval or ratio data, the graph of choice for those is a histogram. Again, a histogram is very similar to a bar chart. There's really only one main difference, and so I'll highlight that when I get to that point. But you'll see the rest of the process ends up being pretty much exactly the same. So if I wanted to make a bar chart or a histogram for any set of data that I've got in a frequency distribution table, the first thing that I have to do is I have to create a set of axes. Along the side, I need to list my frequencies. And the frequencies you can see that I've got here range from 1 up to 8. So I'm going to start with a 0 on the bottom, and then I need to create a set of intervals here. So that's 3, 4, 5, 6, 7, 8. So again, I would recommend, if you're working on an assignment, you use graph paper, or if you're going to your first test where you might be graphing this, you need to bring a ruler to do it. Okay, so I've got my frequencies on my vertical axis. On the horizontal axis, where we would put X, we have to label our categories. But our categories now are not numerical. They're just going to be a bunch of categories called blue, orange, red, brown, yellow, and green, and so on. So I'm going to create a spot for each of those. So this will be green, yellow, brown, red, orange, and blue. And so I'm going to label these. Let's see. Green, yellow, brown, red, orange, and blue. Okay, so far everything is the same between a bar chart and a histogram, except for the fact that I don't have numbers along the bottom. But even with a histogram, what you're putting along your x-axis is all of your X category labels, and so it really is the same so far. But here's where things change a little bit. When I go to make my bar for green, so when I go to take my bar for green up to a frequency of 6, I have to make sure that I don't allow that bar to move or to be drawn all the way over to the next category. I have to keep a space between each one of my bars. Let me show you how I would actually, let me show you what that looks like when I've done that. So I'm going to bring this up to 6. So here is my first bar showing the frequency of green M&Ms, and yellow M&Ms that had a frequency of 1, and so that's going to be to there. So notice I've left a gap in here. Notice that these do not connect directly to each other. This gap is very important. If they ask you to create a bar chart and you don't have this little gap in here, you're probably going to get a significant number of marks taken off, even if you've done everything else correctly. Okay, so why would we do this? Why do we need this gap? Well, let me finish the bar chart off, and then I'll show you what the idea is there, why that's important. Okay, so I need to, for brown, I need to get up to 3. And for red, I go all the way up to 8. For orange, it's 5. And finally for blue, it's 6. Okay, so what's the deal with the gaps? Why do I need to have these gaps? Well, the main reason is there is no particular logic to the order that I've written my categories in. For example, I chose to make green the first category that I put onto my my bar chart, and then yellow, and then brown, and then red, and so on. Why did I do that? No particular reason. I just happened to write down green first. I mean, I know that that came from my table here, but when I made the table, what was the reason for this order? There was no reasoning behind it. These aren't in alphabetical order, and even if they were, why would alphabetical order have any particular importance when it came to colors of M&Ms on a graph? The idea is that if you were to take this graph and rearrange the bars to put these into alphabetical order, what you would see would be a different kind of shape. The shape that you see here goes something like this. But that shape that I've drawn is completely meaningless. I'm not supposed to be trying to draw any kind of a pattern or to see any kind of a pattern as I look from one side to the next. The reason being that, like I said, there's no order to these bars that is important, because these are just categories. These are just colors of M&M. So if I was to rearrange the order, it would completely rearrange this series of peaks and troughs that you see here. So the gaps are supposed to keep us from trying to do this side to side, or to look for a pattern as we connect all of these side by side. Maybe the best way to explain what I mean by this is if I actually was dealing with numerical data. Let's say I'm dealing with data that shows salaries at a company, and you see that at low numbers, like close to 0 salary, you will have hardly anybody making almost nothing at a company. But as you get up towards 30, 40, 50,000, you're going to start to see more and more people that work for a company making those amounts. And then you get into management salaries, and there's not as many managers as there are workers, and so it starts to drop again, and the whole distribution becomes kind of skewed as you get up into upper management and the executives. So this sort of a pattern, as you rise and then fall, this truly does have a meaning. This shows me that as you move up the pay scale, you're going to have more and more and more employees having sort of a regular or median pay scale, like $50,000, $60,000, $70,000, and then that's going to drop down again as you get into the smaller amount of higher paid executives. It makes sense to look from side to side and determine a pattern like that when you have numerical data, proper numerical data, like interval or ratio data on a histogram. But with a bar chart, The order of these bars makes no sense. They're completely arbitrary. At least that's the case when it's nominal data. So we're not supposed to be looking from side to side, because if my tallest bar was at the beginning, it would change that pattern completely. Instead, we're just supposed to look at the bars and their heights as individual distinct units. I'm not supposed to be looking at how green changes into yellow, changes into brown, and so on. That makes no sense. I can just look at the height of green versus the height of yellow versus the height of brown. With ordinal data, you can make the argument that as you place your categories, you would be doing them in the proper order. For example, let's say that we are looking at how much schooling a person has achieved. And so this would be like high school, and then they did some college or university, and then here they've got a bachelor's, maybe here they've got a master's, here's a PhD, and here is a postdoc. Well, in that case, there is an order involved. However, we don't know whether or not the amounts of school are equivalent amounts of school. So it's not like saying with the salaries example, where this category would be, this first category here would be from $10,000 to $20,000, and then the next one would be from $20,000 to $30,000, and then the next one would be from $30,000 to $40,000. These would be all equivalently sized categories, and so we truly can make side-by-side comparisons. What about our education, as I've shown it on an ordinal scale? These are completely arbitrarily chosen amounts of schooling. To get through some college is certainly not the same as achieving a PhD after your master's. So this is perhaps just a little bit of schooling. This is a lot of schooling here. These are not equivalently sized intervals of category. So again, we just have to think about them as being individual distinct bars that we're not trying to get an overall picture of as we move from one end of the scale to the other end. That only happens on a histogram. With bar charts, using nominal or ordinal data, we have to keep those gaps in there to force us to think about these as being separate, distinct units that we're looking at on our scale on the x-axis.